going to be talking about data access layering. Basically, we now have a database, and the problem that we want to solve is we want to be able to use this thing, whether it be for a website or some sort of an application. Long story short, you don't want to have to install SQL Server, SQL Manager on every one of your clients' machines and teach them how to write SQL queries to actually get the data that they want to see. It's often nice to put it in some sort of a format that they can view. So how do we actually use this, or I'm sorry, what is this thing actually all about? This data access layering, we want to, most of the code is actually some sort of an object-oriented sort of a style there. And we want to be able to represent all the data that we're using as some sort of an object. So how do we actually get it to go from a database into an object? And we're just going to build some layers on this thing so that we can actually start using it. This is going to be a lot easier to use rather than writing the queries every single time we want to use them and just looping across the results. It'll also keep us from making mistakes like spelling errors and just typing things wrong. Just to give a quick picture, we have the database at the bottom here, and it's also wrapped together with the concept that we're calling the data access objects. I'll get into exactly what each of these objects do in a bit here. We also have our application, which will be our website or the actual application that you want to run. And then separately, we have something called an object model. This is something that would represent all the tables in the database, along with all the information in those things, such as the columns and if they're required or not. Just a quick example of what this thing would look like here. Inside our program, here's a main function here too. We have this user DAO, assuming that we're going to be using a user. They obviously have like a login name, a username, a password, things of that nature. Just to make a simple query, when we finally go to use it, we would just simply call it like we would any other function. We want to select everything that's in there, so we just call the select all function. It would give us back a list of users, and then we can access them with like we would any other object that you would normally be using. Just a quick anatomy over this thing. Of the actual data access object, that would be the part that we're looking at, the part that actually defines what we can actually use in the database. We have a base DAO. This is something that every other object in here would derive from this one. It would provide common functionality like a select all, a connection string, a way for us to actually connect to the database and ask it questions or do inserts of that nature. Anything else that would be specific to a specific table would be in the model DAO here. This would be where we would define individual queries. Queries for a specific table or for a user we want to be able to log in with them. So we would pass in a username and password, query that against the database to see if they actually entered it correctly, things like that. The third part here would be the object model. This is the piece that it mirrors what's actually in the database. We would create a class, and it would have the definitions for, well, a string where we would have a username, but that's going to be an example a bit later here, just a little bit of foreshadowing for you. The standard approach here, if we were to just regularly make a query, every time we wanted to ask the database, or to query against the database, we'd have to make a connection string, build our SQL statement separately, then connect to it and run our SQL command. This is just some examples of how you would actually do that. The thing here is that we would have to do this for every single query that we want to make, reconnect each time we want, and then loop through the results. This can be very time-consuming. It's also very error-prone. You can also do some, that also leaves room for some malicious code in there too. So you would want your code to be safe against attacks too. This is time-consuming. There has to be a better way to do this. And just an example of what this actually looks like is it gets kind of ugly every time we want to use this thing. So you can see up at the top here we have the connection strings. We go ahead and build a query, and then we run it. And then at the bottom, in this case, we're actually getting out an integer that would be the result from our query. This is kind of annoying to have to do this every time, so let's actually take a look at some issues first. Kind of a redundant point here is that this may be difficult. This also opens up room, as I mentioned just a bit ago, that we can have users that try to sneak in some sneaky code here. With the act of building a string separately, a user could just enter into a field something like a drop table. You guys have probably seen this comment before, but I'll give you time to read it if you haven't. I guess the point in this one is that if someone happens to name their kid with a drop table statement, anytime they go to use that, they put the kid's name into anything, there's potential that, well, you could suddenly lose every single, in this case, a student. We want to avoid this because this means that our data just suddenly got deleted. Just a quick tips on how to avoid this thing. There's only really one way, at least one decent way to actually avoid this. You don't want to create an SQL statement that includes outside data. Long story short, you can't trust users. Everyone's always saying the customer's right. Sometimes they like to insert attacks into your code, and you don't want to let them do that. The best way to defend against this is to use parameterized SQL calls. That means that you separate the call itself from the actual parameters that you pass in. As opposed to you going through the code yourself and making sure that you didn't add any quote signs in there, actually try to run code or look for anything that looks like an SQL statement, you can easily mess that one up, miss a couple of things, and long story short, you won't get everything, and then some code will run for you, and now you suddenly lost all of your students. Not a good thing. The best way is to sanitize your data inputs and put it into a parameter, because then what you can do is actually let the driver that you're plugging into the database with, that will do all of the checking for you, so long as you're using these parameters. So all of the checking is done or taken care of for you, and now you're sure that your code is clean. And you can also make sure that you don't lose any students in here too. I'm not going to go through a quick example of what this actually looks like if we were to build something like this. Just a quick example of what this base DAO looks like. It's going to have common functionality like the update, insert, delete, and select. That's the stuff that we've just spent the past couple lectures going over. Some two new things in here that you might not recognize is the map function and the parameterized statements. The parameterized statements would be the things that that will help you separate the actual string from all the arguments that you want to pass in, basically the input from the user. The mapping will take the result that you have from the result from the query and actually map it back to a data object. It'll go through the records, find the columns, match them up appropriately, and at the end of that you have a complete object that you can treat like any other class in your code. Just to look at what that object looks like for a user, if we have this, the table on the right here, we have a username, a password, a first name. That's what it would look like in the database, and as you can see, we can't have nulls in these things. So if we look on the left here, yeah, that's the left, we have matching fields. You can see that some of the names are matching up here. They might look familiar here. We have a username, a password, a class, or middle name, email, things of that nature, but they match up exactly to the table. This is all in a class, and we can now use this thing when we actually go to use a user. We're treating it as a user object. This actually helps a lot more to go towards the object-oriented way of programming. We're now, instead of dealing with just a result of strings that happen to be coming from a query, you're now using an object that you can pretend is an actual user. It's a representation of a user because it's an object, but you can still use it like one. To look at the user DAO, as you can see, it does derive from the base DAO. In this case, it's deriving from a type with the user so that we can have, when we go to do a select all, we're going to be mapping back to a user object. There's some, the insert, update, and delete are in here too. They're right in the center. They're around here. Then we have some other functions in there too. Some of them might look a little funny here, like the user map. We're getting back an iData record. That is, or the iData record is just the object that we get back from the query. Things like this will let us then map it back to that user like I just described. We also have a couple other functions in here too, and this is where we can make custom queries, such as admin change user password or get password encrypted. A lot of times you don't want to store a password in plain text in the database, so you want to encrypt it. In this case, we're just wrapping that up in the user DAO. We're just going to call a function and let the DAO take care of all the encryption for us. So it's a nice way. You just call a simple function, pass it what you want in, and suddenly it's updated for you. All of this is now managed for you. You don't have to write that ugly string every single time. To actually look at the user, specifically the map function here, we actually, after we get our query back, we're mapping it, we're looping through this record, this iData record object. We're looking for specific names. This would be the result from the query. We would say, as an example of what the select statement would be in this default select up here, we select the ID user, the username, the password, the first name, and all that. That comes back into the record. We're just pulling that out as a string, and then mapping that back into the user. We're creating a new user object and then just filling up the fields in this map function. End result of this thing is we now have a user that we can actually use as a user. Does this mapping concept make sense? I'm thinking this is something new for you guys here. Have you guys seen anything like this before? Is anything? Sorry, what?
Entity relationship mappings, sort of, or object relational mappings, when we were doing some projects. We haven't seen anything like Link, which is something like that.
Link is one way of doing this thing. It kind of wraps up this whole concept and has kind of a funny syntax to it, but it will. This is kind of what it's doing in the background here. This is just a way to do it all by hand.
Okay.
Okay, does everyone kind of grasp where we're trying to go with this? Is basically what Adam's trying to sort of work through is y'all have just sat down and figured out how to build a nice normalized database. Went through an ERD, created the database, and we did a, sort of a lesson on how to normalize it and make your database nice, okay? Now, the biggest question that you have in your travels now is, how am I going to put this stuff in my code? And sort of recapping back a couple of slides, there's a standard approach that you probably have all done so far in your classes where you would create a connection string, open up open up a command object, fill that command object with some string that says select star from table, and then call a reader on that, loop through it, and say, what's in column 1? Great, give that to me, let me do something with it. What's in column 2? Great, that's the last name, let me put that in the last name variable. Let me do all this stuff with it, okay? As you can see, that's going to be really, really cumbersome if you have to do that and you've got 300 tables out there and you're trying to do all this stuff. So what folks have done, and this is something that we've done at B3, is they build these data access object layering systems where the concept of opening up a connection string, looking at the data inside, creating a command, building the command string to actually execute it, loop through it, get the information, is all done in these libraries. And if you start with the base concept of, let's say, SQL Server you're using, and you write the thing for SQL Server, and then you sort of start to specialize those things and say, build a user object that's got the user string in it, the user query in it, and the edit, update, the delete, and all those functions in there. And then now I can start passing objects back and forth into my system. And when I'm out here working on my code, I don't even have to worry about what the database is all about. Okay, is that kind of getting a little bit circle here where we're going with this?
Yeah, I think in the database class we called it object relational mapping.
That's going to be a, isn't that the next, that's the next lesson, okay? But what we're trying to do here is we're trying to, it's kind of like learning calculus, how to do an integral, doing before you learn an integral, you have to learn derivatives, and then you find out that derivatives are, sort of summations of integrals, so how did you actually get there? We're trying to show you this is a way to actually write those things. This is what you would use before those systems came out. Currently, there's a bunch of these systems that are already out there that have matured and become mainstream, but prior to that, you had to write your own. You had to do your own thing. This is an example of how to build one yourself. Okay, so what we're trying to do is show you how those things are built, and then actually in the next lesson, we'll show you what Microsoft has done with these things and actually how you don't have to write these, but you can use them. So, sorry for stealing a little bit of your thunder, Andy.
One thing is we wrote these.
Oh, you did write one?
Yeah. We did some.
It was horrible.
Well,
That's why you've gone over.
That's why you want to go over it. It's something that you kind of almost have to learn how to do. And, because you're going to have to build these things, and then once you build them,
you got to get your data.
If you have these things in your toolbox, and you pull them out, and you've already got them halfway baked, and you just have to add new objects onto it, then your life is much easier. So learning these things, putting them in your arsenal, and then bringing them out when you need them is a good thing. Okay, so we were at about sort of showing you what, the user object going to the user data access object. I think that's where we were at.
Actually, before we get back into this, you did bring up an interesting point there. Since we're layering this concept, where we're separating the database out into its own concept, the model into its own concept, and the application, they're all separate to each other. They're just talking to each other and being able to use each other. At this point, we really don't care what the database is. It could be an MS SQL database, it could be a MySQL, it could be Oracle. At this point, we could swap it out between different databases. The only thing that would have to change then would be the data access objects, the part that actually define the queries. You could still have your application running the exact same and using the same model on this one, so long as all the databases are using the same model. So it's a nice way to make your code not dependent on the underlying data, but still able to use it no matter where it's coming from. Here. Okay, so we were looking at how to map these things. Actually, this right here, what we're showing you, this code, it's part of a homegrown system that we use in some of the programs at B3. This is C# code, so it might look a little funny here, because I know most of you guys are using C++. But what we're doing here is when we do get the query, we get the query back as this record object, and then we're just pulling the information out of it and mapping it back to one of these objects that's defined in the model. So now we can use it as a regular object. So, anyone have any questions before moving on? Awesome. Okay, just a quick look at how we would define an insert statement, an insert and a delete. We would define a string, or our query up here, insert into login user, and give it some value, the fields that we want, and then we're also passing in these parameters. You might notice the funny syntax here, what has the @ sign and then a name. This is part of the parameter. We then make a dictionary object to map these, what would be the parameter, back to the actual value. We're actually now accessing some of these objects here. User.username, we're pulling out the user, user.firstname, user.lastname. So we now have, we've separated the actual SQL statement from the parameters, and then we're passing that into a run non-query thing. Quick note here on the run non-query thing. Part of that base data object, there's two definitions of how you can run a query. You can run a regular query, which would be just a question. You want to write a select statement. A non-query would be something that actually changes the database. That would be an insert or a delete or an update. So if you just want to ask questions, you can actually save yourself from accidentally changing the database if you only ever use the run query. And whenever you want to make a change, you have to run a non-query. So a way of separating this even further, more just to protect yourself from making mistakes, because as humans we're prone to making typos and things like that. After this is run though, we're actually passing in the statement with all the parameters to it. So now we're protected against SQL injection because we passed it as a parameter. And then now we've inserted a new user. Delete works very similar. We pass in a user object, and then in this case we don't need to make as big of a query, we just want to pull out the user ID. So we go say delete from login user where ID is equal to whatever ID we happen to pass in. Again, using parameters here to protect ourselves. An update, very similar again, where we pass it in the user, define our statement where we say update login user, and now we're using a set statement in here where we say set username equal to the parameter, first name, last name. Then again we set our parameter objects and we pass those in and run that. In this case, we're actually then changing the password on this one because in this case we're assuming that the password is encrypted. So we'll go ahead and insert the user. If you notice in the top here, we're not actually passing in the password. We use that as a separate function, this change user, or admin change user password, because we're assuming only the administrator will be able to do that. And we're using this, this password encryption thing here. Encryption's kind of a topic in of itself, but if you're ever interested in it, we're using this system.security.cryptography concept, where Windows does provide a lot of that for you so that you don't have to go figure out how to hash something for you. It will go ahead, hash it for you, give it back to you as a byte string, and now you can actually save that byte string to the database. So now your password's encrypted, you can write that to the database, and you didn't have to write any of that yourself, you just had to write the one function to call it. And then for this change user password concept, we get the encryption, and then we pass it in and save that as the user password. So,
I have a question.
Yes.
Suppose you only wanted to update the middle name of the user. Is it worth the overhead of running this function to update everything? Just to keep it simple?
There's two, the question is suppose you want to just update a single field inside the record as opposed to the whole thing. Is it worthwhile to go through the whole deal and do it all over again versus is there something like that? Perhaps, perhaps not. That's sort of a design decision that you're going to have to make on your own. Does it make sense? From a programming perspective, what you're looking at here is sort of a general system that says we'll provide you with an update and we'll update it, and what you're doing in this case is you're updating something, you're updating food to food, you know, and bar to bar, but Baz might change to zoo, you know. So you're keeping two things the same and changing one object. Okay, that may be a little bit more work than you have to do as far as at the database level, yes, but from the generalized perspective of it, you can. Now, if that's an issue for you at design, then what you can do is you can specialize some of your, this is your own code, so you could create it to say, I only want to do these fields, and then you write the logic to just generally build, dynamically build the call and only put the ones in that you want, or a is old versus new type thing. You could do that kind of stuff if you want. So to answer your question quickly, this particular case, this particular example doesn't do what you were suggesting, but that's sort of a design issue by the programmer who wants to write these things.
If you were to use this way, what it would do is it would copy the same values back into the user. If you're concerned about performance, then what you can do is actually write a separate one to just update the middle name. That would actually run a lot faster because you're not, again, having all of this overhead. Now you can update just the middle name, and then you're good to go. Of course, that would just require writing a separate call here. Does that answer your question?
While we're still on the topic of that, for most business applications, you really don't need to worry about the overhead of just additional fields added in.
Okay.
Generally, there's not many additional rows going into it, but if you actually start coming into a high-performance environment, that's when you need to start adding additional parameters or checks, so it's only updating the ones that are actually changed.
Right. Okay.
Generally speaking, you don't need to worry about it.
Okay.
Let's see. Here's an example of how we can actually start making some useful queries here. In this case, we want to get a user by an employee name. So we're going to pass in a couple strings here. We want to look for a first name, a middle name, and a last name. So we build our statement. We're building off of this default select, which is a couple slides up here. As part of this DAO, we defined what a user select or a default select was. So we're just building on top of that object. So we're saying select, or using the default select, give me the first name where it's equal to the one that we're passing in, the middle name, and the last name, again using these parameters objects. And then we run the query for it. As you can see, what we get back is a list of users here. And then if we actually have a user, or if we actually have results back, then we're going to pass back that full list. If not, we're going to somehow let whoever calls this code know that there were no users back. In this case, we're going to return null. We could actually return back the regular list, and it just wouldn't have any objects in it. But that's defined, or how that would respond would be based off of how you're writing the rest of it, or the rest of this DAO. Another one in here is get user by ID. Again, we're just passing in a single parameter here, building off the default select. We define what we're looking for, and then go ahead and run that query and pass that back to whoever called the function. Then there's one more here. We're getting all the users, or get all users. In this case, we're adding some order to it to make it look nice. The assumption would be that we're just going to put this into some sort of a list on the website so that we don't have to do any ordering after we get the query back. We're actually letting the database do the sorting for us. The next step would be actually integrating the DAO into an object, or into something in our actual application. Let's just assume that we have a website where we want to first come to a login page. So we have some text box up there where the user enters their username and password, and then they click a button that says login. When we go into that, or when we hit that button, we want to somehow verify that we are actually logging in. So we're going to check against the username and the password that they entered in. We're going to call this login function that exists in this DAO. We pass in the username and the password. So we create another one, or we pull up an instance of this DAO object, and then we run the function is login valid. We let it check against the username and the password, and it will come back with, or in this case, it comes back with a Boolean value of if it worked or not. Based off that response, we can then either ask them again for the password or actually log them into the page and take them into wherever they would go afterwards, probably like a main menu or something. Let's take a closer look at the base DAO. Now we had mentioned this run query and run non-query concept, just kind of leaving it out there. But this, you might recognize some things that we mentioned earlier of the standard way of querying a database. We do have an SQL connection and an SQL command. So we're actually passing these things in, so we pass in the parameters. We get our connection, and then we actually run the command here. We then execute this query, and in this case we're actually getting an ID along with that one too. And then once we get our result back, then we close. As part of this execute non-query, and I think this is actually part of the lab too, we're going to want you to step into this function, see what it actually does. The execute non-query will run the command and get the result back. And for whichever object it got called from, say it was a user DAO that actually called this function, it will then map that object, or the result, back into one of these objects that would be in your model. After that's done, we close the connection, and then we're good to go. We're also putting this under a try-catch because, well, we could have made an error in our statement, and we want to be able to tell that something broke. So in this case, we're just going to write out to the console so that we can have some way of knowing what happened or what went wrong. And even if we do have an error, or if it was successful, then we go ahead and clean up after ourselves so that we can dispose some of the memory and then be able to use that sometime later. Does this concept make sense? Oops. Matt, questions? Does this concept make sense of how to actually do a query, run a query and non-query? This does not make sense. Anybody have any questions? Okay, cool.
Okay, what we have for lab 4, if you go up to the website,